Hello all. Let us see a very interesting concept known as a multilayer perceptron network. Multilayer perceptron network, in short known as MLP. Now let us first understand what the title is indicating. Now network means what? As shown in this picture, it is a interconnection between the nodes. Our human brain is containing many neurons and they are connected to each other, and that's why the information is exchanged among neurons. Perceptron is indicating neurons in artificial intelligence. So what this perceptron is working on is it is a node. That node is capable of taking input. This input is features of our data set that we are using for training and testing purpose. So how many features our data set is containing, those all will act as an input to neuron. Another name for neuron is perceptron. So it will process that input and it will produce a output. Now when these neurons are arranged in one line, and we are making use of that only one line, then that perceptron is single layer. And when we want more lines of this neuron, which is a multi-layer perceptron, means we are making use of more than one layer. Now here, what will be the input to this second layer? The output of the previous layer will act as an input to the next layer. So that is what the name multi-layer perceptron network. Now, our MLP is advanced concept than machine learning, but it forms base to the deep learning. Now, let us try to understand the difference between multi-layer perceptron network and deep learning. Now, what is happening in MLP is this is the first neuron of first layer. It will be connected to first neuron of second layer, second neuron, and third neuron. In the same way, the second neuron of first layer will be connected to each and every neuron of second layer. And this will be repeated for all the neurons present in the previous layer, which are connected to all the neurons to next layer. What this is indicating that our MLP is a fully connected network. While in deep learning, you will not observe fully connected network. Some of the neurons of the previous layer are connected to some of the neurons of next layer. Hence, it is called as a partially connected network. So this is what the main difference between MLP and deep learning. Now, what is the architecture of this MLP and how neurons are processing information and how it will be applicable in real life, that we all are going to see step by step. As shown in the diagram, we can see biological neuron. In this neuron, you can observe the biological terms. Dendrite as an input, soma as a body of the neuron, and axon as output. No need of remembering these biological terms. Just remember that our neuron is taking input. That input will be processed and it will generate the output. Now, what do you mean by artificial neurons? Is neurons, those are created by human for artificial intelligence purpose. Now here we observe the input as x1 to xn. Means all the features of your input data set will act as x1 to xn. Then we will assign weights, that is the w1 to wn. Now the most important thing to remember here is x will be multiplied with w, that is xi will be multiplied with wi, which will be called as a scalar product. Then we will add bias to this scalar product, or that scalar product will be compared with threshold. So that is acting as a limitation to our network. Means the expected results accuracy will be controlled by this threshold. So when your scalar product is above that threshold, then that neuron is considered in next layer. So this term is known as neuron is fired. So this is what the main working of any neuron. So what you have to remember here is we will consider the scalar product. The scalar product will be compared with threshold. And if the scalar product is greater than threshold, then in that case, neuron will be fired in next layer. Now let us see the architecture of a multi-layer perceptron network. Now this is what the perceptron, just now we were talking about it. Now here you will observe the term B. B is what? Bias, which is the another name for the threshold. Now what is F? F is the activation function. So there are different types of the activation functions, that is sigmoid, ReLU, Tanha, like this. Each function is serving specific purpose. So that also we will see step by step. Now, let us see multi-layer perceptron architecture. Now, what we see in this diagram is we are having an input layer. So, these are your inputs, which are xi to xn. So, as I told you, you are giving the input as data set. So whatever features you are using for your task, those all features will act as an input. Then each neuron will be connected to neuron in the next layer. So this is giving you fully connected network. Now on this edge only, we are assigning weights. So this xi and wi will be multiplied with each other. That will give you the scalar product. And when that scalar product is crossing the given threshold, then it will generate the output. Let us consider it as a O11. Now why O11 is this one is indicating the first layer, and this is indicating the output from your first neuron. So this O11 will act as an input to the next layer. So what are these layers? These are hidden layers. In each hidden layer, more and more number of information will be extracted. So your feature extraction task is done by this hidden layers. And finally, you will have the output layer. Now, how we are proceeding? We are proceeding in forward direction. That is from input layer to output layer. And finally, we will get our output, that is what? Y. So based upon your classification, if it is a binary classification, then you will get the output as 0 or 1. And if it is a multi-class classification, then you will get an output which is greater than 2. Now, the obtained output is compared with the actual output. This is your actual output. The difference between these two is called as an error. The perfection in prediction task is measured by accuracy. If you want your prediction to be more accurate, then in that case, this error should be reduced. To reduce this error, what you observe is your whole task is based on the scalar product xi wi and threshold. So here xi is the input which is obtained from the dataset that we can't change. Threshold is also generally constant, but the things that we can modify is weight. So using backpropagation algorithm, we go on modifying weights from output layer to the this hidden layer, then from last hidden layer to the middle hidden layer, then to the first hidden layer, and finally to input layer. So the weights are modified based on the error value That is the difference between the obtained output and expected output and the learning rate. So as we are moving in reverse direction, that is called as a backpropagation algorithm. And in backpropagation algorithm, we are using the concept of stochastic gradient to modify the weights. Each step of backpropagation algorithm also we will see in upcoming slides. Now, as we have understood architecture of multilayer perceptron, let us apply it on a simple example. Now, this is what the working of your multilayer forward propagation. Now, let us consider this example. Now, in this example, what we can observe is we are considering only two inputs. Means our data set is containing only two features. Now, this is the expected output, and we are considering the 4 instances in our data set. Now, this is the W1 given by 0.9 and W2 which is also given by the 0.9. Now, let us consider the first instance in which Xi should be multiplied with Wi. So Xi is 0, your Wi is 0.9. So you will get the output as 0.9. Now again, this is over. Now let us consider this one. Again, 0 is multiplied with 0.9 and again, sorry, here we will not get the 0.9, we will get 0 here. And again, when we are multiplying 0 with 0.9, we will get the 0. And when we add both, we get the 0. So this is the obtained output and this is the expected output. What you observe, both are matching, hence no error. Now let us consider the next instance in which 0 is multiplied with 0.9, you will get 0. 1 is multiplied with 0.9, you get 0.9. The summation is giving you the result as a 0.9. Now here, the thing that we have forgotten is this is only the scalar product that should be compared with threshold. So let us consider the threshold as 0.5. Now 0 is greater than 0.5 is false. That's why your obtained output will be 0 only. But here, when your summation, that is the scalar product, is compared with the threshold, what you observe is 0.9 is greater than 0.1. So your obtained output is 1. And when you compare it with the actual output, there is no match, means error is existing. And whenever there is error, to reduce this error, we are using backpropagation algorithm in which we will modify weight by delta by using the stochastic gradient formula. Now, stochastic gradient formula will make use of error as well as learning rate to modify weights. And the weight modification will proceed in backward direction, that is from output layer to hidden layers to input layer. So, summary of multilayer perceptron steps are input is given by your dataset, weights are assigned, both will be multiplied, the product will be summed, it will be compared with threshold, and we will get the final output. This output is compared with the expected output. We get error. To reduce that error, we will use backpropagation algorithm. So this is all about architecture of multilayer perceptron. The real-time use of multilayer perceptron is mainly for image processing task, pattern recognition, object recognition, etc. Hope you liked video. Thank you.